So our audience is dropping in and we are recording. We're going to have a nice webinar today with two speakers. We have Andreas talking about Linux license cleanup disorder and how to dispel it. And we have Reza talking about, well, security, which is obviously a very hot topic right now. SolarWind has been front of mind for quite a few months. Because we've got a relatively busy schedule, we're not going to linger too much in the prelude, but I will show the antitrust policy notice as usual. We display this at the beginning of every OpenChain meeting, and it helps set the context for how we discuss things. Our full policy is on the Linux Foundation website, and of course, we also have our antitrust counsel available if anyone wants to talk with him. But back to the main event. So, with permission, I will kick straight into the schedule with Andreas. Andreas, are you good to start the presentation today if I stop sharing my screen?
Yeah, I'm good to go.
Excellent. Over to you.
Okay. So you should be able to see my screen now.
It is perfect.
Wonderful. So welcome everybody, and thanks for attending my webinar. Just need to get this going. Yeah, my name is Andreas Kutula. I'm the founder of Bitsy, a company focusing on software analytics and open source management. And I've been working in the era of open source compliance for the last 10 years. And I'm very happy to have the opportunity today to present some interesting findings that we found while auditing the Linux kernel for license compliance. And I would like to share that with you today. So as you know, good developers will not write code from scratch. They will know where to get code, and you will find suitable open source components for almost any problem you wish to solve. This improves productivity, reduces the time to market, and reduces development costs. However, open source does not mean free of license obligations and copyright. Some licenses prohibit commercial use or require that the code is published if it is modified. The risks of the violation of licensing and copyright is, for example, that you need to publish derived code or that you miss some of the attributions that you should have in there. So to start with, when we talk about software composition analysis, this is the process for identifying open source software for the purpose of risk management, security, and license compliance. With the rise of open source use in software across all industries, the need to track components increases exponentially to protect companies from issues and open source vulnerabilities. Because a majority of the software creation includes open source, manual tracking is difficult, requiring the need to use automation to scan source code, binaries, and dependencies. A typical software system consists of hundreds of open source components with hundreds of different obligations. To our experience, many developers are not aware of all the open source components that are used to build their systems, mainly because of repository managers bringing in dependencies or big components that themselves consist of many smaller components or components missing a clear license declaration. Or binary components are used which do not explicitly show license information. It is important to know all the obligations, to be compliant, to avoid risk, and to be able to follow the obligations, attributions, or the publication of code, depending on what the license asks for. Today, I will not cover general aspects of open source licensing and risks. Today, I will do a deep dive into Linux, its licensing specialities, and the findings we discovered in some recent audits. Linux is very, very big. A typical distribution will consist of more than 60,000 files. And Linux is split up into a kernel space, which you see down here, and the user space. Code in the kernel space mainly follows the GPL2. And if you add code in the kernel space or modify it, it again needs to follow the GPL license. If you add user applications in the user space, which use the official UAPI only, then other licenses can be used. This is up here. By default, all files without license information are under the standard license of the kernel, the GPL2 with the syscall node. And different license terms are often listed indirectly in the code. The identification of all copyright holders, licenses, and license obligations within a Linux distribution is one of the most complex and tedious auditing activities and may take several weeks. In earlier Linux versions, before version 4.15, many source files lack license information. This makes it difficult for compliance tools to determine the correct license, and a manual check is always very time-consuming. In the following slides, we will see some examples. In this slide, you will see how a license for a file is declared. In the header, you will find author, copyright holder, and the license text. Sometimes the license text is listed in a separate copying file, and the header will only reference this license text. The file in this example follows the MIT license. This is easy to understand and easy to follow for all the users. The next examples are more difficult. Sometimes you may not find the source of the origin. The code may just indicate a name of an author who wrote the original piece of code. This case normally requires to approach the author to clarify the license and to ask for usage permission. Or you may be able to find the original code with a declared license on the internet. And sometimes the code only references a name, which is very difficult to identify, like the letter example, stolen from Wankman. You can try to identify the author by searching the internet, but this may again be very time-consuming. However, the worst case are files without any information, neither author nor copyright holder nor license. We will use this file for our example. The user needs to find out who is the author of this file and who is the copyright holder. And there are many possibilities to do so. You can search in repositories on the internet to find the original. Sometimes the file may have been copied without the license header. You may investigate if this file is part of the other open source package. And you can use tools to identify code snippets or open source packages and then hope to be able to find the license. Nevertheless, it is time-consuming and difficult to clarify and error-prone. So if you need to do that for a Linux distribution, this is a very hard work. So a plan was developed to clearly identify all applicable licenses for all files, to make it easier for users to understand licensing and to be able to be compliant. The cleanup activity worked like the following. All files without a clear licensing information were supposed to get an SPDX header. If there was no license, by default, these files were put under the default license of the kernel, which is GPL version 2. And files were updated with the GPL2 SPDX license identifier. The SPDX identifier is a legally binding shorthand, which can be used instead of the full boilerplate text. The algorithm worked like the following. Starting point was the kernel 4.13 with 60,000 files. To determine which SPDX license identifier to apply to a file, two scanners were used, scan code and WinDriver. Their results were put in a table side by side. Criteria used to select files for SPDX license identifier tagging was, first, the files needed to contain source code. Second, make and config files were included in candidates only if they contained more than 5 lines of code. And third, if the files already had some variant of license header, even if it was less than 5 lines of code. Then when both scanners couldn't find any license traces, the file was considered to have no license information in it, and the top-level copying file license applied. If a file had some form of licensing information in it and was one of the UAPIs, it was denoted with the Linux syscall node if any GPL family license was found in the file or had no licensing in it. When the two scanners agreed on the detected license, that became the concluded license. When there was a disagreement between the two scanners, one detected a license but the other didn't, or they both detected different licenses, a manual inspection of the file occurred. So let's come back to our example file. It did not show any license in version 4.13. None of the scanners detected the license. So it was concluded by the algorithm that this file has to follow GPL. And in the kernel version 4.18, you can see the respective header that was automatically added. The file is now licensed under GPL2, as you can see. However, there was some doubt. Other files of the same driver in the same directory, they all contained the MIT license. The file is directly included in other files showing the MIT license. And these files technically belong together. And digging deeper into this, it can be concluded that the file originally belonged to MIT. So to summarize, during the license cleanup, this file was marked as GPL2 with the described algorithm. However, close analysis of other files in the driver's directory indicated that this file is subject to the MIT clause. This was also recognized by the cleanup team. And if you look in the newest version of the kernel, or in a newer version like here 5.6, the problem is rectified. It's now MIT. And you can see in the commit statement that the update was to correct the GPL header, which was accidentally added to the file. So now you would think everything is fine. But now imagine you are a customer and you're using kernel 4.19. Which license should you use for this file? GPL, as it is indicated in the header, or MIT, as it is corrected in future versions? And if you do not look at future versions on the file, you will not even be able to see the correction. According to lawyers specializing in license compliance, the license cleanup did not intend to change the license of the file. It just happened because the algorithm to automatically mark all source code files in the Linux kernel was not perfect. So this leads to the assumption that the license to be followed for this file is MIT and not GPL, even in kernel version 4.19, even if the header indicates something else. So if you would use any of the standard scanning tools, they will detect the SPDX header and will show a GPL license for the file, which you now know is wrong. So to summarize, the automatically inserted Linux SPDX headers are not always reliable. A manual post-analysis is often necessary. In our audit, we used a script to automatically search for license updates in the commit messages in future kernel versions, so we were able to quickly detect when there were any issues. However, it's always a high effort if you not only check a current version of the kernel, but also need to look in future versions for each file. And a deep scanning analysis is then an essential consideration where you can better analyze all of the files. So this was a very quick introduction in the cleanup of the Linux kernel and what's happened and how we solved that issues. Thank you for listening. Do you have any questions?
Andreas, that was brilliant. My goodness, it sounds like a huge amount of work. How long did it take?
So to look at all of the Linux full distribution takes a couple of weeks by some analysts.
of weeks is quite quick considering the scope of the problem. That was efficient work indeed. Well, I'm going to pause here and let anyone else ask a question if they have one. Ah, there is one here. He has raised his hand. Over to you.
Hey, so a question here. Wouldn't this be, I mean, not for older code, but for newer code, wouldn't this be resolved by having a CLA in place? Given the fact that most CLAs say we can relicense your contributions to whatever we want, which means that, you know, you just then have to just take everything contributed after the CLA was signed and move it to whatever license is the one that's of the moment.
I'm not sure if I got that question correctly.
So what you're doing here is you're looking at older versions of the kernel, but anything that has been contributed to the Linux kernel since there is a contributor license agreement in place, the CLA basically says things along the lines of whatever code you contribute, we can relicense in any way we want. I'm just brutally summarizing, which means that rather than have to look for license descriptors in the code, you could just take every piece of code contributed after the CLA was signed and remove anything that has to do with license and just put GPLv2 or whatever Linux wants.
So it depends if it's in the kernel or not.
True. Well, if it's contributed by somebody that is contributing according to the contributor license agreement, whether it's kernel or maybe there's some flexibility, I don't know.
Yeah, so here I was just talking about the part that is the kernel code. And in the kernel code, that normally has to follow GPL2. However, there are many other contributors with different licenses. And after this correction that was run on Linux, so that's what I want to highlight, that this automatic correction was not, there are errors in there and you need to be careful.
Yeah, cool. I mean, it's amazing work. Great. It's really amazing work.
Yeah, I thought it's a very interesting finding to share because it's not very obvious when you audit these files. Any other questions?
Yeah.
I see we have something from McCoy Smith, I think.
Hi, Andreas. I'm Gautam. Hello?
Hello?
Yes, sorry. I'll just go with my question. So, yeah, so I'm Gautam here. So I just wanted to know, like, what kind of composition analysis tools that is being used in order to determine this cleanup activities?
So for the cleanup activity, that was done by some Linux Foundation group, and they used ScanCode and WinDriver.
Okay.
However, for the analysis that we had run, we used some commercial tools.
Okay, fine. Okay. Fine, yeah, thank you.
So McCoy just raised a point that there's no CLA for kernel. McCoy, is that you? I'll just hand over to you.
Yeah, I was just commenting to the previous question about a CLA, and I am almost certain that there's no CLA intentionally for the Linux kernel. It's done license in equals license out, but plus a developer certificate of origin. So the question about whether you could resolve some of the later questions using a CLA terms, I don't think would apply to the kernel.
Mm.
Well,
I think it just applies to the user error.
Yeah, sorry, that's just, I don't think that Linus will like it if you ask him about CLA on Linux. Linus was pretty much strong about and against the CLA there.
CLAs have gotten a bit of a bad reputation recently, so, yeah.
Well, they're a pain in the butt when you're inside an organization to get one signed. Believe me, we had to struggle for months before we could sign the CNCF corporate CLA to be able to contribute. So, yeah, they're a pain. They're a real pain for everybody.
Yes, it's true.
Okay, so then thank you for listening. If you have any other questions or want to chat, just let me know. You'll see my contact data here. And then we can hand over to the second presentation.
Excellent. Thank you very much indeed, Andreas. That was brilliant. And Sammy just made a note in the comments that people need permission of the copyright holder if they want to change the license. So our next presentation is going to be Reza on security. Reza, are you okay to go?
Hey. Hello, everyone. I think Jill is sharing the slides we put together.
It's just starting now. Okay. Excellent. There it is.
Fantastic.
So it's G and Reza are taking the floor.
Thank you. Thank you for everyone giving time and listening to our presentation. Thank you for the last presentation. Now we're taking to a different conversation around security and how that security and making security a value to conformance and your assurance journey in your organization. So Gilles and my colleague Gilles and myself are basically based in London, UK, and Gilles in Geneva. We both run this presentation together. Just to add that we given not you know, it came quite an ad hoc request, and we try to put together something looking at what we've done with our clients and previous experience. Both of us works as part of open source practice of Wipro, and in a different basically different fields. Giles is strategy advisor of open source, and I'm working on security and consultancy part of the team. Giles, if you move to the next one. We know open source is everywhere in any enterprises. So it's basically disrupted by digital transformation, all enterprises disrupted by digital transformation, open source in the center of this transformation, whether it's in infrastructure, applications, and you know, every corner of ecosystem of an organization is basically touched by digital transformation and clearly by open source and open source software. And we know this is a major issue for IT and IT service management, and basically, you know, it's being in a kind of pain points and the nervous system of any enterprises, which is left some of the questions unanswered around open source software. So now I hand it over to Jill to talk about security of open source software and with some of the examples.
So thank you, Reza. So just to set you know, some context on open source and security, I have three slides of a few factual elements and some horror stories. But the first one is, you know, the question of security by obscurity, which is at the core of whether open source is secure or not. A lot of people tend to say, if people see my code, they'll find my bugs and then they'll be able to exploit them. What is interesting is that there've been over and over for actually centuries now, people who say that the security of a system should not depend on knowing the system, but more on how well the system is designed. You know, and Kirchhoff, sorry, hard to say, expressed it really well when you're saying that the security of an encryption system should not depend on knowing the encryption system, but on the security of the key. And it's the same thing with software. If you're going to secure your code, it's not by hiding the code, it's by making sure that the credentials you use and the algorithms you use are all strong. Credentials secure and algorithm strong. In fact, with Diffie, by the way, I used to work for Sun in the same team as Whit, wrote about this, you know, a long time ago, and it's really hard to write secure code that stays secret. In fact, what I always say is that if you're looking at proprietary code, it means that only the bad guys will get access to the code, whether it's by stealing the code or by threatening and having somebody give them the code, or by bribing and having somebody give them the code, or by somebody making a mistake and publishing the code. In any case, the source code of proprietary systems will leak always over time. And it's kind of like Murphy's Law, right? If something bad can happen, well, Murphy says if something can happen, it will. Code leaking can happen, it will. As an example, when I was a student, I had a full TK50 deck of source code of VMS, not open VMS, VMS, the one that was not open, the one that was running in nuclear power plants. And that means that the bad guys also had access to this code because I didn't have to look particularly hard to find it. The bad guys have access to this code. And that means that if there was bug in the code, they would have found it and exploited it and maybe broke some nuclear power plants. Whereas when you publish your source code, you give the good guys a fair chance of fixing or at least finding the bugs fast enough. The story I always tell here is when I used to work for Sun, when we open sourced Solaris, if you remember Open Solaris, years ago, when we published Open Solaris, about a day or two, was it? Maybe a day after, we get an email from a guy saying, there is a huge bug in login, a really, really bad bug. In fact, if you type this at the login prompt, you buffer overflow and you're root. Here is a patch that fixes it. So we received that about 24 hours after publishing the source code of our operating system. We check the patch, we validate that it works. We send it 48 hours later to our paying customers on support contracts, get everybody updated. And then less than 4 days later, we published the code as part of the next update to Open Solaris. At the time, 2010-ish, it was or 2008, something like that. It was the fastest ever that a security patch was published after somebody discovering and disclosing a bug. And this is really interesting. It's symptomatic of the fact that when you have open source, you give the good guys a fair chance. It doesn't mean they will always work well, right? But it does mean that you give them a fair chance, and sometimes it works well. Sometimes it doesn't. OpenSSL kept some bugs for a long, long, long time before somebody actually audited the code. But at least it gives a fair chance. So one thing that is interesting and that people ask me often is open source more secure than proprietary software? And a few years ago, 2014, and by the way, they don't do this study anymore because after the 2016 studies, they realized that there was open source code in every or almost every commercial code, proprietary code. So the point of distinguishing proprietary versus open source wasn't really, from a coding perspective, wasn't really that useful anymore. But in 2014, when they did a study, they measured the quality of code by counting the number of bugs per 1,000 lines of code. And what's interesting is the little spreadsheet underneath, which says that, which shows actually that for commercial software, the number of defects per 1,000 lines of code is about 0.76 line of code, which is not a lot. It's good. It's still about 1 line of code per 1,000. But for open source, it's in the same ballpark. Right? It's not an order of magnitude below or above. It's really in the same ballpark. It's slightly better for open source. So if you want to nitpick and just say one is better, you can say open source is. But to be honest, they're just as secure one and the other. And there's no real point in actually comparing that anymore recently, because that same open source code, which is in an open source project, also ends up being one of the libraries inside a commercial piece of code. But historically, the comparison was interesting because it was more or less in the same ballpark. And funny enough, even those guys that when I was a Sun, they were our open source enemies. They were the enemies of everybody in the open source world. They say in their report, I put the URL here if you want to read it. The conclusion is interesting. It says basically that having a source visibility does little to increase the security risks. And in fact, in some cases, it actually makes it better when you're trying to stabilize and secure your code. So that's quite interesting that even the company who was the biggest defender of proprietary software, pardon me, Oracle, at a time, is clearly saying, nope, it's just as good or even better in some cases. So that's what I wanted to say as a conclusion to my part, that open source and proprietary software, they're as secure, but the real difference is in the remediation. With open source code, there's a significant chance of being able to fix things before they get too much out of hands. And there are methods for that. And Reza is going to talk about some aspects.
Thank you, Jill. Okay, we don't want to reinvent the wheel. Our management in any organizations, they want to have a level of assurance which basically provide a balance between conformance and performance. And open source is an open source compliance regime is not different from other activities we do. So we want to provide this level of assurance and the balance between these two activities, which organizations want us to do. And clearly, this needs to be basically redefined and aligned with what open source specifically requires when it comes to a specific risk around open source. And we all know that OpenChain, providing OpenChain compliance, is one of the best available ways of dealing with the level of assurance which our organizations requiring from us for open source, use of open source software in our ecosystem. So there are a specific, if you go to the next one, Jill, obviously I'm not taking up a lot of your time, that there are specific aspects or specific activities we need to do, which OpenChain quite clearly defined for us what to do. When it comes to security, again, as I said, there are certain areas of security initiatives which we have to make sure we provide when it comes to open source security. And that basically alignment with open source rather than reinventing anything new. When we talk about policy, we know the policy is something is already been there, but how this policy with the definition of the right roles and responsibilities and the right control regime fits open source, that's the major issue which we need to consider. Then asset management has been part of our security initiatives. When it comes to open source, we have a number of clients in which they don't have the right asset inventory of what is involved with open source, because as famously they say, you can't secure something we don't know what you're securing for and with. So you need to know your asset. You need to know what type of asset you have, and then start monitoring them and putting the right control for them, and have the right security assessment for those assets, and run a gap analysis to understand what is missing with this assessment, with these controls with those assets. Obviously, threat modeling is one of the areas which which give us understand the threat vector and threat players and actors. And again, when it comes to security vulnerability management, which is historically we do with security, looking at a new ways of understanding of vulnerability. If we used to do SAST or DAST, now we need to have a deep understanding of bill of materials. We need to have a deep understanding of software composition analysis, and to understand the vulnerability from a different perspective. And that would be able us to audit our security measures and security controls. And last but not least, as a part of license management compliance with OpenChain, which specifically define that, which greatly will help any all of those above security initiatives which you think, which you are considering for your open source ecosystem in your organization. So my message in here is, first, we we want to make sure we provide the right level of assurance. Looking at what Jill said about security, there are lots of wrong perceptions about open source. We want to make sure our senior management team understand open source and the benefits of open source, as well as the risk around open source, to provide them with that level of assurance they want to see from activities we do to govern our open source software. And the second thing is, we're not trying to start everything from scratch. As I said from the start of my conversation, that we are not reinventing the wheel. We're not making things, we're not presenting new things. We basically make sure that what we do currently all is aligned with our open source governance and strategy to address the risk which our organizations face, whether it's license risk, supply chain management risk, security risk, operational risk, and so on and so forth. So I think I should stop in here and ask if any questions you may have.
Thank you, Guy and Reza, for a brilliant presentation. Well, everyone, this is your chance. You've got the experts on the line.
Either we were super clear or we bored everybody.
We're gonna go with super clear.
You don't have to answer this one.
I suppose one question I've got relates to the complexity of implementing open source security policy around, well, open source versus the policy making scene in, let's call it, traditional software approaches. So if we look at how a bank made a security policy when they bought Solaris in 1995 versus how a bank could make a policy regarding their adoption of OpenSUSE, do you see the process system a case where they're going to have to throw out everything, or they can just make a few adjustments and manage their open source security adoption?
Something between these two, Shane, I would say. One of the major obstacles we see around open source and governing open source is a lack of understanding. As you perfectly know, OpenChain doing a lot of, I mean, I've looked at the education material with what OpenChain prepared in respect to training. It is really important for organizations to understand what is open source and how open source is different from commercial software, and what are the similarities, what are the differences. One of other thing is when it comes to security, is a lot of developers or development communities, they don't have enough knowledge around security. So they need to be trained about security. They need to understand why security is important, how security should and would work when it comes to software initiatives like SDLC or assessing threats around software. So I think it's something in between. There are some organizations you will see they need to basically reorganize, reformat the policy and how the policy should and would work. But currently a lot of organizations are moving towards the right direction. But whilst they're moving towards right direction, the lack of understanding of awareness of open source, that's the big issue.
That makes a lot of sense. That makes a lot of sense. Oh, by the way, you have full confirmation that you were clear, not boring in the comment section. I see Sammy's got his hand up, so over to Sammy.
Hello, yes, hi, Reza, thank you very much.
Hi, Sammy.
Very well and very clear. I actually wanted to just make a comment. I think security vulnerability is actually much more of a challenge if you look at it as compared to license compliance, because with license compliance, you have almost a static sort of a scan or a sort of look at the open source to determine what do you need to do. Whereas, of course, with security vulnerabilities, this is ongoing because you have to, you know, at the point you start to ship your product, to distribute your product, that security vulnerability might not be known or might not even exist at that point. But of course, these things can change, and those vulnerabilities might be identified after that event. So you have to continuously continue to scan to sort of check, has anything changed from last time we did this check. I mean, how do you see that sort of managing that in an organization? Because I think, you know, there's an element of there's a huge amount of effort that is needed, which probably puts off a lot of organization, because you need to sort of spend a lot of investment in setting up that infrastructure to be able to do that.
I think one of the elements I'm sure you're quite aware is automation. So if you automate this process as much as you can, obviously you can't automate everything, but automation is one of the answers from a technology perspective. The other thing is your traditional security vulnerability team, they may not be aware or understand. Again, come back to the understanding of open source and the challenge of open source, and also when it comes to different components of open source, because they may see a commercial source code which has got dependencies on that. So that basically one of the elements. So if you ask me what can be done, I say automation, training, and also audit. So if you on an ongoing basis provide the right level of audit, which you also test your controls at the same time, you probably will respond to the challenges of security vulnerability management. But I mean, at the same time, we all know it's a big challenge. It is quite difficult when it comes to if you're practically looking at it, it is challenging. And I agree with you, Sami. It's not an easy job, yes. But maybe we can do with you know, more automation to answer that.
Okay, thank you.
Thank you.
Brilliant. Any other questions?
Gilles, if you go to the next one, I think, no, not next one. I think our email address is slide number 2. So if you need to contact us with any questions you may have, we are more than happy to, you know, to answer them. And both of us are in OpenChain Slack channel. So yeah, any question can be answered there. Thank you.
Brilliant. And if we don't have any further questions right now, just a big thank you to Andreaski and Reza for your presentations. Big thank you for our active audience. We had quite a busy lot of people on the call today. The recording will go live in about 48 hours for the rest of our global community. I will see you all here in about 2 weeks for the next webinar. And before that, of course, we have our global work team call in 1 week. Thank you, everyone. Have a good morning, afternoon, or night, depending on where you are.
Thank you, Sean. Bye-bye.
Take care.
Thank you. Bye.
Okay, bye-bye.
Bye, everybody.
Thank you.
Bye.
Thank you.